Welcome back. Ooh, Bangalore is boiling, so hot. And today there's no power, so there's no AC working. So, anyway, my name is Osale Mahana. I have taught A-level maths for a long time, and I'm just going over all topics in pure maths at A-level to help you people revise and go over what you have learned in school. Yeah? So we were doing lots of examples. I've done up to 5. In fact, actually, in one of them, the title says set 5, but if you see inside, it's 4. We're trying to make it into 5. Our IT experts are trying to do it. If not, after 4, it's 5. And I think I have forgotten how to count. Doesn't matter. Today, set 6 is correct based on that. All right. So let's look at I think I had gone up to, I think I had gone up to U or something like that. So let me just call it as number 1. Use the substitution t equal to 1 minus x sorry, 1 minus x squared to evaluate integral 0 to 1 x power 5 1 minus x squared power 6 dx. Yeah. You've been given a substitution, it doesn't say otherwise, so you have to use the substitution. How do we use it? Find dt by dx is minus 2x, so dx equal to dt over minus 2x. And whenever you change the variable, you must change the limits. So therefore, when x is 0, t is minus 1. When x is 1, t is 0. Please, just because minus 1 is smaller than 0, you don't need to change the limits. Correspondingly, you must put, so this becomes integral 0 to minus 1. Oh no, sorry, minus 1 to 0. I did exactly what I told you not to do. X power 5, I can't do anything, t power 6 dt over minus 2x. I'll take it over there. 2 rules. Whenever you interchange the limits, you get a negative sign. Meaning, look, when you put the upper limit minus lower limit, but if you change, the limits change, so the answer will change. So you need a negative sign to make sure the answer is correct. Or the other way of looking at it is, whenever you have a minus sign, you can absorb the minus sign by interchanging the limits. So, I don't think I should do it, but let's do it. So, it becomes 0 to minus 1. Okay. X power 5 becomes x power 4. X power 4, a half, t power 6 dt. X power 4. X power 4 is x squared the whole squared. X squared is 1 minus t. So x power 4 is 1 minus t the whole squared. So it's half integral 0 to minus 1, 1 minus t the whole squared times t power 6 dt. There are 2 ways of doing this. One is integration by expanding the brackets. The second way would be integration by parts. Just out of interest, I would do using integration by parts. So I'll rub off all this. I will rewrite the question there so that I can continue from there. So it is half integral 0 to minus 1. It should have been minus 1 to 0 by absorb the 1 minus t the whole squared t power 6 dt. Let me do first using the expansion and algebraic method. So it is integral 0 to minus 1 half 1 minus 2t plus t squared t power 6 dt. That is half integral 0 to minus 1 t power 6 minus 2t power 7 plus t power 8 dt. That is half times t power 7 over 7 minus 2t power 6 over 6 plus t power 9 over 9 between the limit 0 and minus 1. So it is half of minus 1 over 7 minus t power 6 minus 1 over 3 minus 1 over 9. And you can see, I think it's the easiest. Let's simplify it as it is. You will still get the same answer even if you didn't change the limits and interchange the limits. So 21. So the LCM is 9 times 7, 63. Half of, I can remove 63 as LCM, minus 1, 7 9s are, 3 21s are, 9 7s are. So the answer is, I don't have to thank God, go back to x's. So it is minus half 37 over 63 or minus 37 over 126. Yeah, just because you got a minus sign does not mean you get rid of the minus sign. No. The only time you will get rid of the minus sign is when you're finding an area. If you're not finding an area, do not get rid of the minus sign. I don't want to do it the other way. Let's leave it there. I could use integration by parts, but I think it's a bit more complicated. I will use integration by parts in another question. Don't worry. So let me take another question. I'm looking for substitutions. Yeah. Express one over 1 minus x power 4 in partial fractions. Again, some of this may not be applicable to students doing at Excel, but it doesn't matter. Hence, evaluate integral 0 to half 1 over 1 minus x power 4 dx. Okay. Right. Partial fractions. So I can factorize this as 1 minus x squared 1 plus x squared or 1 minus x 1 plus x and 1 plus x squared. Factorize the denominator completely. Having factorized it, I could change this to a over 1 minus x plus b over 1 plus x plus is something over 1 plus x squared. Remember, if it was x squared, I could factorize it. It was 1 minus x whole squared, I could factorize it. If it was 1 plus x the whole squared, I could factorize it. But it is 1 plus x squared, which cannot be factorized. So the denominator is a quadratic that cannot be factorized. Then the numerator should be 1 degree less than the denominator. So the numerator will be a linear expression. So multiply throughout by that. So I get 1 equal to a times 1 plus x times 1 plus x squared plus b times 1 minus x times 1 plus x squared plus cx plus d times 1 minus x times 1 plus x. Whew. Put x equal to minus 1. That goes. 1 plus 1 is 2, 2 plus 2 is 4b. So b is a quarter. Okay. Put x equal to 1. That goes. 1 plus 1, 2. 4a is 1. So a is also a quarter. Now I have two more unknowns to find. So what I'll do is, I'll put x equal to 0. What do you get? 1 equal to a plus b plus d. Look, a is quarter, b is quarter. Quarter and quarter is half. 1 minus half is half. So d is half. I have to find c. The best thing to find c will be coefficients of x power 4, because you know why? Here I get x cube, here I get x cube, here I get x, x, x. So coefficient of x power 4 is 0. That means minus c x power 4 is 0. So therefore c is 0. So therefore the partial fractions now become, if I can write it here, so integral 0 to half 1 over 1 minus x power 4 dx equal to quarter integral 1 over 1 minus x dx plus quarter integral 1 over 1 plus x dx minus c is half, d is half, plus half integral 1 over 1 plus x squared dx. That's the whole use of partial fraction, so that you can integrate now. So let me rub this off and rub that off too. So therefore, that is 0 to half, 0 to half, 0 to half. I haven't changed the variable, so I don't have to change the limits. So it is minus quarter ln 1 minus xy. Can I integrate directly? Yes. I use the most important formula. Integral f dash of x over f of x dx is ln f of x. When you differentiate the denominator, I get minus 1. So I'll write this as minus and a minus. So it becomes minus quarter ln. When you differentiate 1 plus x, you get 1. So it is quarter ln 1 plus x. Plus half times. Here, when you differentiate the denominator, you get 2x. There is no x in the numerator and you can't bring x. So the only way you do it is standard formula. Tan inverse x gives you 1 over 1 plus x squared. So when you integrate 1 over 1 plus x squared, you get tan inverse x. Half tan inverse x between 0 and half. So quarter, it's ln 1 plus x minus ln 1 minus x plus half arc tan x between 0 and half. So that is quarter ln 1 plus x over 1 minus x plus half arc tan x between 0 and half. Put half, I get quarter ln. 1 plus half is 3 over 2. 1 minus half is half. 3 over 2 divided by half is 3. Plus half arc tan half. When I put 0, it becomes log 1, which is 0. Arc tan 0 is also 0. So that is your final answer. Got it? I'll just do one more question. Nice substitutions. Ooh. if x equal to cos, use x equal to cos squared phi or cos squared t to evaluate integral half to 1 plus x power 3 over 2 divided by x root x times 1 minus x dx. Lovely question, isn't it? What I would do in this question is do all the working outside and then put it at one go instead of doing bits and pieces. Alright? X is cos squared t. So dx by dt is cos squared gives you 2 cos t gives you minus sin t. So dx equal to minus 2 sin t cos t dt. I could write it as sin 2t, but I don't want to at the moment. So let me leave it there. Change the limits. X is half. Then cos squared t is half. Cos t is 1 over root 2. So t is pi over 4. X is 1. Cos squared t is 1. Cos t is 1. T is 0. So I have changed those. I've got the limits t equal to pi over 4 to t equal to 1. Now 1 plus x power 3 over 2 divided by x root x times 1 minus x is 1 plus cos squared t power 3 over 2 divided by cos squared t root of cos squared t times sin squared t. Let us put all these things so it becomes integral pi over 4 to 0 1 plus cos cube t divided by cos squared t times cos t sin t times dx is minus 2 sin t cos t dt. You see the reason why I didn't change it? Because I can cancel these two. Again, I absorb the minus sign by interchanging the limits. So it becomes integral 0 to pi over 4. I can remove 2 out. 1 plus cos cube t over cos squared t dt. Life became so easy now. Split it. So that becomes equal to 2 integral 1 over cos squared t plus cos t dt. That is, of course, 0 to pi over 4. So that's integral 0 to pi over 4. 2 remains there. Sec squared t plus cos t dt. Right. Now I have to rub all this. I am sorry. I hope you have understood all those. So let me take the final step and write it down. So the question becomes 2 integral 0 to pi over 4 sec squared t plus cos t dt. That is 2 tan t plus sin t between 0 and pi over 4. So that is 2 tan pi over 4 plus 2 sin pi over 4 minus 0. That is 2 plus root 2. So if you persevere, you will be able to arrive at the answer following the steps. So let me stop at that stage. It's too hot. I think I'll wait for the power to come back before I continue. Otherwise, I might just collapse because of dehydration. and stuffy. It's a closed room and no AC, no air circulation. I'm sweating and I'm finding really hot. I'll hopefully come back once the power comes. See you. Bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.